Hey you guys, this is a video that's going to walk you through the lab that we did in class. And the lab that we did was a precipitation lab. It was between calcium chloride, potassium phosphate as our reactants. So here you can see the reactants in a balanced reaction. And over here what we got was our products. We got a precipitate, the solid, which was calcium phosphate. Now in this video I'm going to be giving you a lot of information. Everything that's highlighted in yellow is given to you. So you can assume that if this was a test question, I would give you everything that's highlighted in yellow. And you can see that it even extends down here. Now, the required information is just the things that are highlighted in purple, meaning that if I only gave you the stuff that has these purple dots next to it, you should be able to solve the entire problem. So you need to know that one of the reactants is calcium chloride, one of them is potassium phosphate. The original grams of calcium chloride was 2.008. The original grams of potassium phosphate was 2.012. The volume of solution of your calcium chloride was 40.00 milliliters, and the volume of solution of your potassium phosphate was 40.00 milliliters as well, because I added water to the salt. You would also need to know the mass of your filter paper, which was 1.349 grams when it was empty. You would also need to know the mass of your empty flask, which was 78.256 grams. That is given to you, but you would need to know these things in order to solve the problem. You would also need to know the mass of the filter paper after you dehydrated it. So after it's on a hot plate, you boil off the water, the mass of your filter paper is something that you're going to need to know the mass of. So that is given, but it would also be required. So it's 2.635 grams with the salt and the filter paper. And I also gave you the mass of the flask after you dehydrated the water from the flask, and it's 81.045 grams. Now what you're going to desire, what you need to know is you're going to want to know also this. I should have highlighted that as well. The desired is you're going to want to know the other salt that is inside of your flask. And there's actually two of them. There's two salts that are in there. You're going to want to know, so there are two salts that are in here. You're going to want to know the theoretical yield of your calcium phosphate in moles and in grams. You're going to want to know the actual yield of the calcium phosphate in grams, your percent error of the precipitate, your percent yield of the precipitate, and that's it. Those are the things that you are going to be asked to solve for. And I gave you, not only did I give you all of the required information, but I also gave you all of this extra information. I balanced the reaction for you. I gave you the molar mass of everything. Okay, and I even told you what was on top of the filter paper. Hopefully that's obvious that it's calcium phosphate, but I told you that it was calcium phosphate, and I gave you one of the ions, one of the salt compounds, I should say, that are in the flask. Now there's a bonus question. The bonus question is in green. See if you could figure out the theoretical yield of salt that's in this flask. What salts are they? And how many grams of each salt there should be. So pause the video now and try to solve for everything here using everything here. Okay, using all of your givens that you see at the top, as well as the mass of the empty filter paper and the empty flask, and the mass of the filter paper once it was dehydrated and it had the salt, and the mass of the flask once it was also dehydrated and had salt in it. Pause the video now. Try to solve for all of these desired units, these desired components of the experiment, and also see if you want to challenge yourself. Try to solve for the bonus question, and then you can play the video after you've tried to solve for them, okay? So pause it, and then when you come back, I will start to solve it for you. So hopefully you paused it, and you're challenging yourself. And now you can watch me go through step by step, and you can check your work against mine. So the first thing you're going to want to do is figure out the moles of each one of your reactants, because we use moles, not grams, when we're using stoichiometry. So I take the grams of the calcium chloride, which is 2.008 grams of calcium chloride, and I'm going to convert that into moles. So if I have 1 mole of calcium chloride, I divide it by the molar mass, which is 110.9 grams, and I will get the moles of my calcium chloride, which is 0.01811 moles of calcium chloride. I'm going to place that right in here, 0.01811 moles of calcium chloride. Now, if I want to, I can find the molarity of that. But before I do that, I'm going to just continue on with finding my moles. I'm going to find the moles of my potassium phosphate. So if I have 2.012 grams of potassium phosphate, I can multiply that by 1 mole of potassium phosphate for every, and I go up here, 212.3 grams. 212.3 grams. And I will get my moles of my potassium phosphate, which is 0.009477. 9477 moles of potassium phosphate. And I'm going to put that right into here, into my data table here. 0.009477 moles. Now, if I want to find the molarity, I simply take my volume and I convert it into liters, and then I divide the moles by the liters. So I'm going to divide both of these moles, I ran out of room there, by 0.04 liters, because if you convert 40.00 milliliters into liters, what you get is 0.04000 liters. So if I divide both of these numbers now, I'm going to just change colors to make it a little bit more obvious, by 0.04000 liters, and I divide this one by 0.04000, that's a 4 liters, I will be given the molarity. Okay, and so this one is also the molarity. And you don't need the molarity to solve for this, but I'm just going to draw an arrow here. But it's just practice for you, because molarity is part of our unit. So on this one, when we solve for the molarity, what we get is 0.4527 molar calcium chloride, and over here what we get is 0.2369 molar. So hopefully when you did your work, when you paused the video, you were able to solve for the moles pretty easily, I hope. And then you were able to figure out that 40 milliliters is 0.04 liters. And then you were able to divide the moles by the volume in order to get the molarity. Now let's take a minute and let's draw Magic School Bus style what is in each one of these so we can try to visualize it. So inside here we have calcium 2 plus ions, and we have chloride 1 minus ions. Over here we have potassium 1 plus ions and phosphate 3 minus ions. Now when I add these together, you see these arrows, I'm going to drop both of these into the same beaker. What we get is a precipitate. And the precipitate, if you look at the balanced reaction, is your calcium phosphate. So my precipitate here is my calcium, right, phosphate. We need a 2 there. And then in the solution, I know that I have potassium ions and I have chloride ions. But what I don't know is I have an excess reactant. Now, is that calcium or is that phosphate? And we don't know. We don't know what that is. So in order to solve for the theoretical yield of the calcium phosphate, we're going to have to figure out which one is the limiting reactant. So what we're going to do is we're going to take the moles of each one of these reactants. I'm I'm going to change colors once again. And I'm going to convert them into moles of the precipitate, which is moles of the calcium phosphate. So here we go. So if we have 0.01811 moles of the calcium chloride, and we now convert this into 1 mole of calcium phosphate. Oops, sorry about that. Let's try to undo that. 1 mole of calcium phosphate, like that. That's a 4. Right? And for that is for every 3 moles of calcium chloride. This is in a 1:3 ratio. What we will get is 0.00, sorry about that, 0.006037 moles of calcium phosphate. I'm not having trouble writing the 4s. Now we're going to compare that to using the moles of the K3PO4. So the moles of the K3PO4, there's actually less moles of K3PO4. So let's see what happens there. If we have 0.009477, and that's a 4, moles of K3PO4, and I multiply that times the balanced reaction, which is 1 mole of calcium phosphate. Got my 4 that time. Good job. For every 2 moles of potassium phosphate. Okay? And what you're going to get there is 0.004739 moles. 39 moles of calcium phosphate. Okay. Now what you do, if you remember your rules, is you cross one of these out. And the one that you're going to cross out, hopefully you're saying, is this one. And this one I'm going to say, this is my theoretical yield, my TY. And this over here is now my excess reactant. This over here is my limiting reactant. Yeah? And I'm going to just draw again what's in here. This is my precipitate. So this is my calcium phosphate. Yeah? So keep on with the drawing. This is the K plus. This is the Cl minus. Now we know what is the excess reactant. So there's also going to be calcium 2 plus ions in here, because they are the excess reactant. Are they not? They are. So we now know kind of what we're looking for. We scroll down here and we say, well, we know the moles of the theoretical yield, so we can plug that in. That goes right here. So that is, as we just said, 0.004739 moles of potassium phosphate and, of calcium phosphate, 4739. And then in the grams, we're just going to multiply that times the molar mass for every 1 mole of calcium phosphate. We have a certain number of grams. We scroll up here, we look at the molar mass of calcium phosphate is 310 grams. And so we multiply that times 310 grams. When you do that, you get 1.469 grams. Like so. Okay, so you're getting close to filling all this in. Now, what is the actual yield? Well, that is a simple subtraction. That's the mass here of your filter paper, the original filter paper, 1.349 grams, and the mass here, which is 2.365. So minus 1.349 grams, and that will give you, this is the paper, right? This is the paper plus the salt. Salt plus paper. So that will give you the salt, right? And so the mass of your salt in grams is the actual yield is 1.286 grams. 1.286 grams of what? Of calcium phosphate. Okay. So that's your actual yield. So now you can find down here, you can go 1.286 grams. 1.286 grams. That was just a simple subtraction. So now to find the percent error and the percent yield, let's do the calculations over here. Your percent yield is your actual yield over your theoretical yield, because this is, just so you're clear, this is calcium phosphate. It is, percent yield formula is simply actual yield over theoretical yield times 100. So what we're going to do now is we're going to say the actual yield is 1.286 grams over 1.469 grams. And again, multiply it times 100, and we're going to get a percent yield of 87.54%. So we can put that in right here. That's our percent yield, yeah? So it's 87.54%. And that was our calculation. Now what about for your percent error? Your percent error is a little bit more complicated. Your percent error, and we'll just put the formula here in case you forgot, is your absolute value of the actual yield minus the theoretical yield over the theoretical yield times 100. So let's do that calculation right here. So the actual yield, again, is absolute value 1.286 grams minus 1.469 grams. I divide that, that's an absolute value symbol, by 1.469 grams. I multiply this times 100, right? And I will get a percent error of 12.46%. And we can plug that in right there. And that would be all you would be asked to do on the test. Now let's say you enjoy chemistry, you want to challenge yourself, you want to prepare even more for this exam. Now you try these bonus questions. So let me walk you through these bonus questions, and let's do it. So in here, this was your ions, this was your potassium, this was your chloride, and because the calcium was in excess, you also had calcium ions. Now on here was your precipitate, right? This was your PPT, your precipitate. So this is your calcium phosphate, right? But we've already figured out the calcium phosphate. That part was easy. Now your challenge question is, what's in here? What's in here? What salts are in here? Now KCl is in there, but now let's look what else is in there. What else is in there? Well, now there's calcium chloride. So there's also one of these question marks is, this is calcium chloride, because that was your excess reactant. Now, what is the other salt? Think about it for a second. The other salt is calcium phosphate. You did not have a 100% yield. Some of your calcium phosphate must have gone through the filter paper. Either you went over the edge like this, or there was a hole and it dripped through. And if it was cloudy at all, some of you guys didn't have any cloudiness at all. You did a great job. But some of you guys had a lot of cloudiness. That's your error, and that's okay. So the other salt is your precipitate. It's the calcium phosphate. Now, try and figure out how many grams of each one of these there are. How many grams of KCl, how many grams of CaCl2, and how many grams of calcium phosphate there are. Okay, so you can either pause the video now and then try it on your own, and I'll walk you through it after, or you just keep on watching me go through it right now. So here's what we do. we say to ourselves, okay, we take the limiting reactant and we're going to convert it into KCl, and we can find out how many grams of KCl there are. We also take the limiting reactant and we convert it into the excess reactant, and we figure out how much we have left over, just like you did in the other one. And then we can find out how many grams of CaCl2 there are. And then this one's a little bit more challenging. We'll do that one in a second. So let's do it right here. So let's take our limiting reactant, which we have moles of, which is 0.009477 moles of the K3PO4. Now, if I multiply this, and we want to do the times a balanced reaction, right? The balanced reaction, we're going to go into KCl. There are 6 moles of KCl for every 2 moles of the K3PO4. And when you do that multiplication, what you get, and division, what you get is 0.02843 moles of the KCl. Oops, KCl. Now, if you multiply that, 0.02843 moles of KCl times the molar mass, and I already gave you the molar mass, right? The molar mass was 74 grams for every 1 mole of KCl. You're going to get 2.119 grams of KCl. So let's place that down there, 2.119 grams. So you should have 2.119 grams of KCl. Now let's do the same thing for the calcium chloride, but that's a little bit more complicated. Let's change colors so we can kind of see the distinction between my calculations here. So now I have 0. Let's actually block this off so you can just kind of create some arbitrary divisions between steps. So over here we have 0.009477 moles of your limiting reactant, which is K3PO4. You multiply that now times your excess reactant, which is your 3 moles of your calcium chloride for every 2 moles of your potassium phosphate. Now, when you do that reaction, 3 over 2, you get how much you use, which is 0.01422 moles of calcium chloride. Now that is, as we said before, how much we used. We've done this before in class on a lot of different problems. That's how much we used. Okay? Now how much were we given? Well, we already figured that out. It's right up here. We were given 0.01811. Okay, so we didn't actually have that much left over. So what we'd say is, okay, given minus used. So I say, I'm going to actually write out the words given minus used will give us, there we go, will give us our excess. Right? So we were given 0. Let me pause that for a second. Oh, I cannot. We were given, of my calcium chloride right here, 0.01811. Okay. Oh, sorry, right there. 0.01811 moles of the calcium chloride. And I used 0.01422 moles of my calcium chloride. I'm just going to do a quick little, and so when I do a quick little subtraction here, I just do 0.01811 minus 0.01422, and I get 0.00389 moles of calcium chloride. Okay. Now if I take that moles of calcium chloride, 0.00389 moles of calcium chloride, and I multiply it times the molar mass of calcium chloride, which is 110 grams for every 1 mole of calcium chloride, Okay, I will get times 110, I will get 0.4279. 0.4279 grams of calcium chloride, like that. So we put that 0.4279 grams over here, 0.4279 grams of my calcium chloride there. Last but not least is the grams of the calcium phosphate. Okay, and so what we do there, we're going to block this off. I'm going to just do this in, maybe I'll block this off in red. So this was finding out the, because it's getting a little bit crowded, yeah? Okay, now last but not least is we're going to find the grams of our, okay, there we go. Oh, went a little too far. We're going to find the grams of our calcium phosphate. So when I do that, I'm just going to do it down here so we have some more room. I'm going to take my percent yield. So if I had an 87.54% yield, what that means is I have 0. Let's try that again. Not writing. And right there you go. Okay, it's just getting a little bit slow. So I'm just going to erase those. 1, 2, 3. There we go. So I have 0.8754 times my theoretical yield. And the theoretical yield is right here. The computer's getting a little bit slow, but it was 1.469 grams. So it was 1.469 grams of calcium phosphate. So, and you know what I have to do? I apologize. I have to do 100 minus this. Let me erase that really quick. There we go. And so 100 minus 0.8754. So it's just 1 minus 0.8754. And what this will equal then is about 12%, 12.46%. So 12.46% of our theoretical yield never made it through. It didn't make it through. It was our error. It was how much we lost. This is how much we lost, how much went into the flask. So if you multiply that, what you get is, right, 0.1246 times 1.469. What you get is 0.1830 grams of your calcium phosphate, like that. So this is 0.1830 grams, like that. All right, and then those 3 salts, if you add the 3 of those together, and then you took the mass, so let's add those 3 together. So 0.183 plus 0.4279 plus 2.119, the 3 of these, the sum of the 3 of these is 2.730 grams of salt. And that is what should be in the flask. All right, it should be 2.730 grams of salt in this flask. So now if we took the original mass of this flask, which was 78.256, so if we took 78.256 grams, which is just the flask, right? And then we added it to this, 2.730 grams, which is the salt that we should have. We add those 2 together, and I think I made a little mistake when I was doing this, so let's just double check. Okay, what we get is 80.986 grams. So I need to just correct this. This should have been, I made a little mistake, 80.986. So So when I was doing my original calculation, I just made a little mistake. So I apologize if you had paused the video and you were using this mass, right? But this mass is correct now. Should be, unless, could have made another mistake, but hopefully not. But this mass should be 80.986 grams. And what it is, it's 78.256 grams of the flask and 2.7306 grams of, 2.730 grams of a salt. And then here's how that 2.73 grams breaks down. So hopefully you learned a lot from this video. Again, the test won't be nearly as hard because it won't have any of this bonus stuff on there. You will need to solve for the amount of an excess remaining, but it won't be as difficult as this. It won't be in this lab-based format. What you'd have to do is just using all these givens that I gave you, you would just need to solve for these blue pieces here. That's it. The green pieces are much more difficult. Yeah, all this up down here. On a different problem, I would ask you to find the excess remaining, but I would make it much simpler for you. All right, have a wonderful break. Please email me if you have questions. Use this for a study guide, and that's it. See you guys on Thursday.